Hello everyone. Today let's solve the problem flag. Right. So this was asked in the code forces around 567 division 2 for the division 2. Right. So let's see what the question states. Before that, you can just go through the question, man. This is easier to understand. They have given a crystal clear explanation here for the question. Right. So you can just go through the input and output as well, along with the examples that they have given. Right. So let me summarize the question so that it will be easier for us to solve the problem. Right. So let's see what the question states here. We have an n into m grid. Just give me a second here. 1 second. Yeah. We have n into m grid, right? So just remember this. We have n into m grid of colored cells, of colored cells, nothing but letters, right? So we have n into m cells of colored cells, nothing but letters, right? So we have to count axis aligned subrectangles that form a flag. What we need to calculate here, we have to count axis aligned this one subrectangles. So I'll just give here axis this one aligned subrectangles. Just remember this, right? So we have to find axis aligned subrectangles, right? So this is the main thing that forms a flag basically, right? So we have to find the axis aligned subrectangles that form a flag, nothing but three horizontal stripes stacked equal height c, each stripe one uniform color and adjacent stripes different color, right? So this you have to keep in mind, right? So when I say count axis aligned subrectangles that form a flag, nothing but three horizontal stripes stacked, this is one thing, equal height c, this is second thing, each stripe one uniform color, this is third thing, and finally adjacent stripes different colors, this is the fourth one, right? So simple, very simple. So let's move on with the third point here. What we need to finally count, or what we need to what is our main goal here, we have to count every distinct position. Again, we have to count every distinct position. What we need to count here, we need to count every distinct position, right? So I'll just write here distinct position. Just remember this one, right? So we have to count every distinct position. Right, so this is one thing, man. Right, so this is about the question basically. Let me read this one loudly. Right, so this is one thing, and this is one thing. Right, so these things just keep this in mind. So we have an n into m grid. So this one, we have an n into m grid of colored cells, nothing but the letters of colored cells in the sense letters. Right, so we have to count axis aligned subrectangles that form a flag. So this one, axis aligned subrectangle that form a flag. When I say this, this is nothing but three horizontal stripes that is stacked, equal height C, each stripe one uniform color. This we know. This is the third one, and the final one is adjacent stripes different colors. Right. So these are the 4 points that we need to keep in mind when I say count axis aligned subrectangles that form a flag. Right. So this is one thing. Finally, we have to count every distinct position. What we need to count here? We need to count every distinct position, right? So every distinct position in the sense same look but the different place, right? So I hope this is fine, man. Right? So this is about the question basically. This is about the question, right? So let me come to the input output part here. This is nothing but n. This is nothing but m, right? So this is nothing but n. Again, this is nothing but m here. So this we know. Now we have been given this one grid basically triple A, triple B, CCB as well as DDD, right? So this is about the input basically. We are not considering entire approach now. Let's consider this one approach differently, right? So next, let's go with the approach by considering the same first example. The output that we need to get here is 6. I just wanted to discuss the input output part. So this is nothing but the n. This is nothing but the m. Again, so we have been given this thing. What do you call grid here? This one A B B C C. So this one, the output for this one, we need to get here as 1 basically, right? So this is fine. Now we are done with the flag part. So we are done with the I mean question flag basically. So I hope the question part is completely clear along with the input output. Let's do one thing. Let's quickly discuss the approach followed by the complexities and then let's write the code, right? So I hope the question part is completely clear, man, along with the input output, right? So just give me a second. Let's discuss the approach as usual first. So I have considered the same first example that they have given in the question, right? So just give me a second here. So this is nothing but m, this is nothing but m, right? So this is nothing but the grid. Basically the output that we need to get here is 6, right? So let's move on with the step-by-step explanation here. So first, we have considered the first example where n equals 4 and m equals 3, right? So let's see the this one step by step explanation. So here grid, we have the grid basically row 0 nothing but this one, this is nothing but row 1, this is nothing but row 2, and this is nothing but row 3. So I'll just mention row here, row, uh, this is nothing but row, this is nothing but the row. So vertical streaks head, so we can just consider in this way, right? So we can go with the row 0. For the row 0 we can, as we have the same letters, we can go with triple one, right? So as we have the, again for the row 1 also we have the same letters, we can go with triple one. So for the row 2 we have one different letter, so we'll be going with 112. So h is nothing but here in this case, so row 3 also, so this I forgot, row 3 also we have the same letters, we'll be going with triple one. So here in the row 2 we have one different letter CCB, so we'll be going with 112. So this is fine. So hedge, so as we are going with a vertical streaks edge, we can just represent in this way, 0 1 2 1 2, because this one, this is nothing but the row 2, right? So for the row 2 we got 112, this one. So basically from this one, we are considering I or j, so we have 0 1 and 2 ij, right? So these are the three numbers we have. So 0 1 and 2 we are considering, so this belongs to whatever we have written, row 0, row 1, row 2, row 3, right? So we have three numbers, 0 1 2. So now first one triple one, this one row 0, this one row 1 also triple one, row 2 112, because we have one different letter, and row 3 we are going with triple one. So this is fine. Now let's move on with the second step, nothing but candidate triple stripes at I comma j with a c equals h of ij. So we need three different stripes as they have given, right? So we need three stripes of height c basically. So I, this one I has to be greater than 3c minus 1, and h of ic and j has to be equivalent to the c basically. So we can just write it on this way, h of I minus 2c j should be greater than or equal to c, right? So in simple terms, let's move on with this one, I equals 2, so you'll understand this one better. So here we are considering j equals 0 nothing but c equals 1. So accordingly with the grid we are considering, right? So j equals 0, c equals 1, column 1, j equals 0, c equals 1, I bar j we have considered, right? J equals 0, c equals 1. We will be checking the rows from 0 to 2, from 0 to 2, from here to here, this part, right? From 0 to 2. So this we have from a b c, right? So this is valid basically. So this is valid because we are finding the three stripes of height c basically. We have this one, so this is valid. So when j equals to 2, same thing we'll be looking into, right? So we will be checking from 0 to 2. Again this is valid, right? So again this is valid, right? So when j equals to 2 and column 2 we are considering, we need greater than or equal to 5. So this will be false. We have considered j equals to 2, c equals to 1, right? So first we did, now we are going with j equals to 2 and c equals to 2. So we need greater than or equal to 5, this will be false and it will be invalid. So this we will not be considering. So this one, just give me a second here, 1 second man, what happened to this one, just 1 second. So yeah, this will be invalid basically, right? So now we will be considering at j equals 3. So we'll be going with j equals 0, c equals 1, j1 c1 and j2 c1, right? So now and fine, we will be going with this one as well. Yeah, horizontal we have to go next, we'll be going with the horizontal one. This is fine. Now we had considered from 0 to 2 till now. So as we are going with j equals 3, we'll be considering from 1 to 3, from rows 1 to 3 basically, right? So this one, 1 to 3, right? So don't get confused here, we're going from 1 to 3, right? So this is okay, right? So this j equals 1, c equals 1, we have already considered this one, this is valid bro, this is valid, right? So this is again invalid. J equals to 2, c equals 1, this is invalid, right? So h of 2, this one, this is equivalent to 1, so this is invalid. So structurally valid columns are 2 0, 2 1, 3 0 and 3 1. So these are the valid columns, right? So 2 0, 2 1, 3 0, 3 1. So let me come here, 2 0 is nothing but this one, 2 0, 2 1 Just give me a second here. 2021 30 and 31, right? So just give me a second, 1 second here. 2021 30 and 31, right? So this one has to be 1111 basically, right? So this is fine, right? So now we will be going with a horizontal extension, this one check via prefix p, right? For the column 1, so we will go from again rows 0 to 3, all are equal, right? So row 0 to 3 in the sense here. For the column 1 we are considering, for the column 1, where is column 1, man? See, column 1, this is the column 1 actually. All the values are equal here, 1111. So all are equal here, right? So this is fine. Sorry, all are equal, right? So for column 2, rows equal at 0 1 3 but not at 2, right? So this one we are considering, right? So sorry, for the column 1, this is the column 1, right? Column 0, column 1, we are considering. Sorry, that I showed for this one basically. I had to show for the middle one, column 0, column 1. So this one also, this one equal, right? 1 1 1 1. We have column 2, we have to consider this one, right? So we have 1 1 2 basically. We have 1 1 2. For the column 2, rows equal at 0 1 3 but not at 2. So this is fine. We know this one, right? Now we'll be considering DP. So one thing I didn't mention is we will be going with a dynamic programming to solve this particular problem, right? So the approach that we'll be going with, uh, the approach we'll be making use of is dynamic programming to solve this particular problem. So now we will be going with a I equals to 2. So same thing, first what we will consider when j equals 0 and j equals 1. So we will start and dp is 1. Dp is initially 1. So plus 1 flag we will be considering here, right? Plus 1 flag. So j, when j equals 1, last 3 rows we are considering. So this one from 0 to 2, um, at column 1 match. So this one we will be extending basically. At column 1 match the left neighbor. So this one will be extending. Dp equals dp of 2 comma 0, as we are going with the last 3 rows 0 to 2. So this one will be 2 comma 0 plus 1. So this one will be plus 2 flags, right? So total will be 2 plus 1. This one will be 3. Total so far we have found here as 2 comma 0 plus 1. This one, 2 plus 1 it will be. So total will be 3 basically, right? So this is fine. Now again we'll be going with I equals 3. So we'll be starting again. Dp equals, initially it will be 1. So we'll be going with a plus 1 flex when j equals 1, last 3 rows. So this time instead of 0 to 2 we'll be considering 1 to 3. So at column 1 match, so we'll be going with the left neighbor. Again we'll extend. Dp equals dp of 3 comma 0 plus 1. So this will be again 2. So basically total, final total we get a 6 here, right? So final total will be getting here as this one basically 6, right? So here from I equals 3 we have got 6. From I equals to 2 we have got 2, right? So the final, so sorry, total we have got 3, right? So I got confused with the flags basically. So here we got 6. So the output that we got here is 6 basically. In simple terms, the output that we got here is 6, right? So the output that we got here is 6. This 6 we will be returning as output basically. So the output that we got here is 6, which is equivalent to the output that they have mentioned for the question 1 within the question, within the problem, right? So the output that we got here is 6, which is equivalent to the output that they have given for the example 1 within the question, right? So this is it for the approach part. Uh, our approach works absolutely correct, right? So next, as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, right? So what would be the time complexity here? The time complexity would be because n into m. Why it is n into m? Because we will be visiting each cell exactly once, and we will do only big O of one work per cell, nothing but HP and DP computations, and also big of one checks, right? So overall time complexity would lead to big of n into m. So what will be the space complexity here? The space complexity would be big of n into m as well, because we'll be going with a 3 auxiliaries, right? So when I say 3 auxiliaries, we'll be going with n into m arrays, nothing but HP and DP stored. So overall space complexity would lead to big of n into m as well, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into m and big of n into m respectively, right? So I hope the complexities part is completely clear along with the approach. As we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. So let's start writing the code. I'll just come to the compiler here. So we'll be making use of the fast input and output. So I'll just go with java.input output package. So here java.input output dot star. Also different utilities we'll be making use of. So I'll just go with java.util dot star. This is fine. Next, let me consider the class here. So this one, let me go with public first. Public class. So I'll just consider main here. So I can just consider any name. I'll just go with the main. That's relevant to the this one question basically. So I'll just consider main. Let's consider main method. Let me remove this one. So I'll just go with a throws exception, or else we'll be getting error. This is fine. Yep. So within the main method, first thing, let's make use of the buffered reader and print writer. So this will be buffered reader new main. This one string argument. So this is fine. Sorry. What am I doing, man? Sorry. Buffered reader. So I was thinking something else. Sorry. This one will be new input stream reader. So this one basically comes from system.in. This is fine. Did I miss anything? So there should be one more this thing right here. This is fine. Let me go with a print writer. So this one output equals new print writer. Let me give system dot out. So this is fine. So the next step would be let me go with a string tokenizer here. Tokenizer. This is fine. Let me go with st equals new string tokenizer. So this one will be buffered reader dot read line. This is also fine. Now let me go with n equals sorry, this has to be, we are going with the input n and m, right? So this basically both are the integers. So I'll just go with integer. So this one will be percent as string tokenizer dot let's go with the next token. Next token. Also let's do the same thing for m as well, shall we? So I'll just go with m equals, so let me copy this one entire thing as it is integer as well, right? So this is fine. um Next, let me go with a char. We have the characters, right? So in the grid. So this one, let me consider G here. So this one will be new char of n. So this one will be m. This is fine. So finally, I'll just go with the for loop. So this is fine. So this will be int I equals 0, I less than n. So this one will be I plus plus. Oh, let me opening parenthesis. This is fine. Now this will be g of I equals, we have to read. So I'll just go with the buffer reader dot read line. Let's convert this one to the this one. Let's make use of the two char array here. This is fine. So we are done with this, but we are reading each row here, right? So previously we are considering the grid of characters here. This one n and m input, we know this one, right? N rows and m columns. So this is fine. Next part is we have to compute, right? So let's do one thing. Instead of solving this one within the main method, let's make use of another helper method called solve. Let's solve the main logic there, and let's make use of the helper method within the main method. Let's do that. That's fine. So I'll just come out of this one entirely. So let me go with static so long. So this one, I'll just name this one solve. So this one will be n int m also, so this one will be g. This is fine. Now within the solve method, let me do one thing. Let's go with this one. What do we call h and p? Basically, vertical streak length as well as the cumulative count we have to consider, right? So for the vertical streak, this one length, I'll just go with int h equals new int of this one grid. We have considered n rows and m columns, right? So I'll just go with n. So this is fine. For cumulative count, so I'll just go with same thing in different variable. So this one will be new int of, so I should have copy pasted and made the necessary changes. So this is fine, n and m respectively. Now let's go with the dp, nothing but the number of cumulative columns ending at j, right? So we'll be making use of the dp as I've said, or as we had discussed on the approach. So this one dp will be new int of this one n and m respectively, n rows and m columns. So this is fine. So we need to store somewhere the solution. So I'll just go with the answer and let me initialize this one to 0 initially. So let's iterate the rows, nothing but top to bottom. We will be going with a top to bottom approach, right? So one thing, let's iterate rows top to bottom, and let's iterate columns left to right. So so I'll just go with here. Mm, so just give me a second here. Yeah, so this is fine. And so this is for the rows. For the columns, I'll just go with int j less than n j plus plus. So this is fine. So this is for the, we are just iterating over rows and columns. This is fine. Within the for loop, what we have to do, we have to start from the value from row I minus 1, right? So we know this one. So I can just write it in this way. If I greater than 0, p of I j, so this one will be equivalent to p of I minus 1 and j. This is fine. Now if this cell is equivalent to the left neighbor, so that this, the same thing we had discussed in the approach as well, if this cell is equivalent to its left neighbor in the same row, so they, then we have to increment the columns, this thing, what do we call that one? How can I say? Just give me a second here. 1 second. We have to increment this columns counter basically, right? So yeah, right. So yep, we have to increment the column counter. So I can just write it in this way. The same way, this one, if j is greater than 0, so let me consider here g of ij. So this one equals g of I j. So this has to be column we are considering, right? So j minus 1 to p of I j. This is fine. P of I j. Let's increment this one. So this is fine, man. Let's do one thing. Let's build a vertical streak hedge. If same as column above, then we will be extending the streak. Else we will start at I. So this is what we had discussed on the approach. Again, we have, or we will be building the vertical streak hedge, and if it is same as the cell above, then we will be extending the streak. Else if it is not same as cell, or if it is not same as the above cell, then we will not be extending the streak. Instead we will start at 1. Just remember this. That's what we will be doing here now. So this will be h of I j, sorry, wait, I keep 0 here. Let me scroll, just give me a second here. Yeah, h of ij. So this is fine. uh this one will be I if it is equal to 0, or g of ij. So this is fine if it is not equal to g of I minus 1 j. This is also fine. Oh, where did this go? So why did I close this one here, man? This should be here. So 1 else we have to display h of I minus 1 j, we will be going with plus 1 based on the index, right? So this is fine. Now let me assign c to h of ij. So why we are assigning this one column or the c to candidate to this one h of ij here. So candidate this one, this is nothing but the candidate stripe height. We know this one, right? So it starts from the bottom stripe, right? This is fine, man. Now let's go with the DP transition. Basically, what we'll be doing here, we have to check if there exists three stripes of height c accordingly with the question, right? So I have stressed this one during the question, but if you would have listened to this properly, then you would be knowing. So now we are going with the DP transition. We have to check if there exists three stripe of height c and that end at row I, right? Mainly what are all the conditions that we'll be going with here? So one thing is we need at least 3 into c rows. We need at least 3 into 3 rows, 3 into c rows. What was the condition? If you remember, I greater than or equal to 3 into c minus 1. This one I had said, right? So this is fine. The second condition is the middle stripe, right? So the middle stripe is height c, that is nothing but h of I minus c into j, that has to be equivalent to the c. The third one is the top stripe, right? That has at least height c, right? So that has at least height c. So these three conditions we have to write. So let me write, let's start with the first simple condition. I'll just go with the simple if condition here. If I greater than or equal to 3 into c, and so let me consider h of I minus c of j, this one c of j, this one, if it is equivalent to c, somewhere I did something wrong. Did I? No, this is fine. Yeah, c, and so why here? Oh yeah, this one h of I minus c I should have written. So this is fine. Instead of closing the square bracket here, this is why I'm putting square bracket here. This is fine. If it is equivalent to c and h of I minus 2, so into c, this is fine, j, so this has to be greater than or equal to c, man. So within this, what we're gonna do here, so I write with the, what, where did I write this one? Sorry, 1 second, let me write it in the next line. So this one is fine, this one is fine, this is fine. Yeah, sorry. Now we have to go with the count equals how many of the last 3 into c, uh, last 3 into c rows, right? So that's what we need to do. Have equality with left rows, right? So let's see. And also we need to use the p. P we have already used somewhere, this one. uh, we also need to use the p to compute that quickly, basically, right? So let's see how can we articulate that one in the form of code, right? So I'll just write here int count, I'll just consider cnt here, p of I j minus I, this one greater than or equal to 3 into c. This is fine, that's true. Let me make use of the ternary operator here. This one will be p of I minus 3 into c. This is fine, to j. This one is fine, this is also fine, right? So now what we're gonna do, if all the 3 into 0 match the left neighbor, so we can extend the width by this one. we can just extend the width by dp of I into j minus 1, right? Otherwise we have to start a new width segment. So this we know. Now how can we articulate the same thing in the form of code? I'll just write the simple one more if condition here. If count, if it is equivalent to 3 into c, so this one let's represent dp of ij equals, so this will be if j greater than 0, then we have to display dp of I. So we are considering this one for the column, this will be j minus 1, else uh yeah this is fine, else 0. So I'll just go with plus 1 man. So else we'll be going with dp of ij, this one equals 1. So this is fine, let me come out of this one entirely. So now what we will do, let's add the number of valid widths that is ending at this column to the answer. So I'll just give you answer equals answer plus dp of I and j. So finally we need to return the answer, right? So let me come here. So we need to return the answer, nothing but we are storing the total number of flag subrectangles within the ans variable, right? So answer, I have initialized that one to the 0. So let me return ans. So this is it for the basically helper method solve, right? So we have successfully written that one. Let's make use of this one solve within the main method. Let me copy this one, this is fine. So let's come to the main method one. So let's come to the main method where we have left. So we have to um, so just give me a second here. We are only left with the last two part, right? So we have to compute and print the answer, as well as we have to flush the output, right? So let's do this one, two things. So I'll just go with out.println print result. So this one will be what are the things that we need? Rows, columns, and G. So this is fine. Did I miss something? Oh, we are doing this one within the solve, right? So I did copy this one. Let me paste this one. Helper method. So let me give one more parenthesis here. This is fine. Finally, let me flush the output. So I'll just go with out.flushman. So this is fine. So we are done with the coding part. So this is it for the coding part, right? So let me do one thing. Let me quickly copy paste the signature starter template before checking the code with different inputs, right? So just give me a second here. So I'll just come here. So let me paste this one entirely, man. So this is fine. Now I'll just come here. So let me scroll to the bottom. So I'll just copy this one. The output that we need to get here is 6. Let's see. Oh, we have illegal start of the expression where line number 47. Same thing. 2 errors. We need something wrong I have done here. So yeah, uh, line number 47. Let me come to line number 47 here. So we have to give this one. Just give me a second here. 47 is this one, right? So yeah, I have done a mistake here. 47. This one, if j equals 0, I have started. I have closed the this one parenthesis here itself. Instead, I have to close parenthesis here. That is the reason it is screaming actually. Yeah, we are getting the output 3 now. This is fine. We have to get the output 6, right? So somewhere we have done the wrong. So let me copy this one. We have to get the output 1. Let's check what is the output that we'll be getting for the second one. Just give me a second here. So this is fine. Let me run this one. We'll be getting the output, but wrong output, I guess. Yeah, we are getting 0. We have to get 1. Right. So just give me a second here. 1 second. So yeah, I see this one. And the line number 51, what I have done here is we need at least 3 rows, 3 C rows that is ending at the index I, right? So this has to be actually 3 into c minus 1, I believe. So we need three stripes of for the flag, right? So let me run. Sorry, I have to copy the input. Let me copy the input here. So let's wait for some time. And yeah, let me copy this one. Now this has to work correctly. Yeah, now we are getting the correct output, right? So this was the problem basically. For the we are considering three zeros, this is fine. So that has to end at the index I, means minus 1 we have to give. That is nothing but 3c minus 1. So I just considered 3 into c instead of 3 into c minus 1. So that was the mistake. So that was the subtle mistake, right? So this is fine. Now let me consider this input. So the output that we need to get here is 1. Let's see what output we'll get for the second example. So yeah, we are getting the output 1, right? So now the code works exactly correct for the the code works correct for the inputs or the examples that they have given in the question. So let me copy this one entirely, the code. Let me come here, let me scroll to top. So let me hit the submit. Let me come to the submission part. So let me paste the code over here. Let me hit the submit button again. So I hope this works for all the test cases, man. Let's see. Let's wait for some time. So you can clearly see here in the toast it is showing accepted, right? Even in the verdict that we got here as accepted. Means whatever the code that we have written works absolutely correct for all the test cases, right? So we have purely made use of the DP here. We have went with a DP basically to solve this particular problem, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.